Before the start of a new semester, the Disability Services Office informs professors when they will have a student who is blind or a student with low vision in their class. One of the professors, Dr. Steve Jennings, when he received this notice, he contacted me and let me know that most of his material was visual, and he asked my advice on what he should do about this. After some discussion, we determined that we could use a couple of different methods to create some tactile materials as an alternate form for this student. Dr. Jennings also meets weekly with the student to assist her in interpreting this material that's been created for her.
What looks accessible to a student with high vision doesn't necessarily mean that it's easily accessible for a student with low vision. For example, a professor gave us this printed image of geological water tables. In addition to the lack of tactile lettering, there are other challenges involved in making this diagram an accessible one. Let's take a look at the most obvious flaws in this diagram. For starters, the dotted line that is supposed to represent the water table could be obscured by the large amounts of rock. Also, this flock of arrows is repetitive and confusing. Due to the image's low resolution, the grass near the surface water is blurred into a singular blob. Most of the image has a gray background. This gray may be just dark enough for the thermoform printer to raise it along with the rest of the lines, making the dark, important lines difficult to distinguish. Therefore, the image will need to be whitened. Finally, many of the lines lack the thickness and intensity that is standard in tactile imaging. In this case, it cannot simply be scanned in and printed off. Some sort of editing will need to take place in order to make sure that the image can be read with clarity. To do this, we have two options. One is to redraw the image in a simpler version, or edit it on the computer. For an image with so many obstacles, oftentimes it is simply easier or quicker to redraw the entire diagram than to edit it within a computer program. With some thin printer paper, tracing over the original image with an extra fine point marker is a cinch. The new lines are thick, dark, and will scan in beautifully on our high-resolution scanner. Many times we get rid of unnecessary components such as the font, lines, and arrows in the hand drawing, as accessible ones will be added via a computer. After the image has been redrawn, it looks much simpler compared to the original. Using our fast action high resolution scanner, the redrawn diagram is now saved to the Assistive Technology Lab's computers and is ready for any necessary computer editing. For the editing example, we will be showing you a different image. In order for us to get the right contrast for the final thermoform form, we need to adjust the colors on the image. This is necessary because the swell touch paper only swells on the specified black or dark lines. Knowing that, we need to make sure that black and white colors are being used correctly so that arrows and other objects can be read easily. Once the image is drawn appropriately, we need to add text that describes different parts of an image. To do this, we use a software called View Plus Braille Translator. It's as simple as copying the text you would like, translating it within the software, and pasting it in the image as Braille text. Here are the pictures of the images from start to finish. We start with an image that is not correctly fitted to the page. We then delete text and arrows so that we can modify the colors to meet the final printing requirements. Now we end up with an image that is ready to be printed and used by a student. Standard printing paper is not suitable for the thermoform printer. A special kind of paper known as swell touch paper is heat sensitive and will swell on any part of the paper that is marked with black lines. Thankfully, any black lines will cause the paper to swell, so as far as printing the diagram off initially, using a regular printer is fine. When the image has been printed onto the thermoform paper, it can now be fed through the tactile image enhancer. This produces a safe but efficient heat as it automatically feeds the image through. To ensure maximum readability, we set the dial to the highest level of swell. In just one cycle through the tactile image enhancer, the image and associated braille lettering are now raised and accessible for the low vision student. Here is a before and after image of the printed diagram. As you can see in the second image, the black lines have completely thickened from their original flat ink printing. The student now has a completely accessible tactile diagram at their learning disposal.
I have a blind student this semester. I've been teaching for over 30 years. It's the first time I've had a blind student, so I began to think about how I might be able to help her out. So I was able to take data that's been collected by the U.S. Geological Survey. It's what's called pixel data, so it's small areas of the Earth's surface that have been assigned an elevation. And I've been able to use that and convert those files into a file that can be used in a 3D printer. I take the data from the USGS and I use several software programs to convert the information. Once I create the file, which has it's called an STL file, I can then send that to Cory Gavitt up in UCCS Teach, who has the 3D printer. On these models, these are somewhat hollow. They have a grid underneath it, so it's not all completely plastic, just that top surface. The student has been proactive, but obviously there are obstacles to someone taking a class like this and not being able to see some of the representation. It's one of those things that is good for the UCCS classroom, but also has some implications for other folks around the state.
Thanks to the effort of these professors, our dedicated student workers, the Disability Services Office, and many caring folk, at least one more student has access to one more class and hence the opportunity to succeed. Thank you.